This is Entangled by Visumation. I already recorded in video, but in French, and I think this is such a nice puzzle. It deserves an English version also. So, for the rules, we have normal Sudoku rules. So every row, column, and 3x3 box must contain all the digits from 1 to 9. And then we have palindromes in grey. So I apologize if I keep calling them renban sometimes, but it's a palindrome. So it reads the same in one direction or the other, from one end to the other. So let's say if it were 1, 2, and then 3 here, then it would have to read also from this side the same way. So 1, 2, 3. So it could read 1, 2, 3, 3, 2, 1, or the other way around. So that's for the palindrome. Then in purple here we have a renban. So it contains a set of consecutive digits in any order and non-repeating. So these two must be different. We have German whisper line in green. Any pair of adjacent digits must have a difference of at least 5. We have here in peach, we have an entropic line. At every 3 successive cells along the line must contain a low digit from 1 to 3, a medium from 4, 5, 6, and a high from 7, 8, 9. And it applies for every 3 segments like this. And finally we have killer cages, so these, the digit in the cage sum to the given total here, 6, 14, and so on. And that's for the rules. I can't promise I will be as spontaneous as I was in French, but this is really fun. I would start here because the renban is more constrained than others, I think. So the usual question is, where goes these digits? Somewhere. And I will ask, where does it go in this 3x3 box? So this digit, let's give it the color, let's say yellow. It can't go elsewhere on the renban, of course not here but also here. And since this is a palindrome, it can't go on these 3, so it can't go on these 3 either. So it doesn't go on the renban nor on the palindrome, so it goes here. And for this digit, it's similar because it can't repeat on the palindrome, on the renban. It sees these 3, so it can't repeat on these 3 either. So again, it must go here. So let's use yellow again, and for this digit it's the same, can go on the renban, can go on the other side of the palindrome, so it must go here. And so this is indeed all these 3, can't have anything else but these 3. And we can do the symmetry, so this one in this region can go on the renban, no on the palindrome because it sees these 3, so it can't go there either. So it goes here. So let's call, and then the same for this one and this one. So these 3 is yet another. Let's use here red for this one. It's another triplet like the yellow one, which goes here. And then for this row we have, let's use grey for instance, which are indeed the digit on the palindrome, which is repeated. So these two are the same, these two and these two. And indeed, maybe it's more interesting to think first about the palindrome, then about the renban itself, because these three digits can't go here, which are the same as these three because of the palindrome, so they can't go here either. So the digits on the palindrome for this row are always on outside. And so now this is a renban, so it must contain a set of consecutive digits. So first here, this is 6, 9 or 7, 8, and the others are 1, 2, 3, 4, 5. The renban is 6 long, so it must contain 4, 5 and 6. Which means that we can't have, on the palindrome, can't have 4, 5, 6. So there's no 4, 5 here, no 6 here, so no 9, because 6, 9. It must contain 4, 5 and 6, so it must contain a 6 somewhere, here or here. If it were here, this would be 6, 9, which means that the renban, because this is indeed the renban, this is the left side, and this is the right side. So these must form a set of consecutive digits, and they must include, so if this was 6, it would be 6, 9, and the 9 would require including both 7 and 8. This would be 7, 8, but one of them is not on the renban. So these three are the one on the palindrome. So if this were 6, the 6 were there, this would be 6, 9, but there is only one 7 or 8 available here. So this can't be 6, 9, but 7, 8, and so this is 6, 9. Now we have 8, but no 9. So we must include all other digits, but 1, 2, which goes here. So now there's a 6 here, 7 and 8 here. On the palindrome we have 9, 1, 2. And won't note these three because this is too many options. And then we have some sort of roping here, but this is screwed roping. I don't know what to call it because we have these two yellow goes here and this one goes there. Well, indeed, these three goes in the bottom and these three goes here. But there's no constraint here, so that's probably not the way to go. So now I will continue with this one. Maybe it's more interesting to think because whichever triplet goes on the palindrome is repeated there, so it must go there. And we have the same here. We have a palindrome of 3. It's giving a color like these two. So let's give it a light gray color. So these three, which are the same triple, doesn't go there nor there, so they go here. Then we have the same indeed. Maybe we will color these because we have alternating low and high, so let's do it this way. These three, which are not the palindrome, must go in the column somewhere, so they must go here. And we have here 6, 9 or 7, 8 again. So these three, so we have two of some sort and a third one. So we cannot have a single I digit here. So we have at least two I digits, or indeed we have two I digits. These two and a low, so these are I. These are I. I will use orange and blue for I and low. So these are I. 7, 8, 9. Can't put a 6 here. So could place a 6 there. So it could be 6, 9, yes, and this one goes here. This is 1, 2, 3. Can't put a 4 here, no, here. So could place a 4 here. This one is this one, so 1, 2, 3. And this pair, this triplet in this column is not on the palindrome, it's not there, so it goes there. Which means we have two low digits and a high digit. I will write it like this, just to remind us. So with 1, 2, 3, 4, and here we have a quad on the low digit. 1, 2, 3, 4, so there must be a 4 here, which match this one, so there must be a 4 here. 4 goes with 9. So this is 7, 8, which are these two, because these are the same. So 7, 8 here, and this is the 9. Well, not that way. I mean, there is a 9 in here. This is, we don't know the place exactly, no, but there is a 9 in there, and a 4. And so no, there is a 7 there, so we can't place a 3. This digit is this one, and now we have 1, 2, so we need here these two. We have a 1, 2 pair with a 4, but we need this can't be 1, 2 because it goes there. So this is 3. 3 can go next to 7, so it's 8, 7. This could be anything. Well, I mean 1 or 2. 3, 4, 9, which are these 3. 7, 8, and 1, 2. And then we have here in the column 5 and 6. So the 5 and 6, of course, can't have a 5 German whisper line, so it must go somewhere here, just to remind us. So we have another 1, 2, so these two are the same, these three are the same. We have the other 1, 2 on the palindrome, and 5, 6. But, well, here we have some mini palindrome of 2 cells, so this is 4. So these are the low, these are the high. 4 goes with 9. 7, 8, this can't be 6, but this could be 6. 1, 2, 3. Well, this can't be 3 because we have at least a 7 or a 6. Well, we can do the same indeed. This triplet is the same as this triplet. So in this row, it goes here. Which means there is a 3 on the palindrome. So no, this can't be 3 either. Then this digit and a 7 or 8. These 3 is the same as for this one. And these here and palindrome here. Well, there's no 5 on the. There's no 5 here on the German whisper line. So for the rows, well, maybe I should think first of. So we have 9, 4, and then 1 or 2. 9, 4, then 1 or 2. Here we have this one goes there, this one too goes there, and this 4 goes there. So we have 2 low here, which are these 2, 1 here, which is this one, so 2 and 1, and then a 3. So again we have a triplet, but on the low this time. So 1, 2, 4. So this can't be a low. 1, 2, 4, and 3. This can't be a low again. So it's here we have. So these are 5, 6. Not this one. 5, 6, and this is 1, 2. This one. And then 5, 6. Well, we could deduce it some other way, but yes, but we have also 6, 7, 8, and 9. So 9 goes there. This pair goes here. So we have 1, 2, 3 here. And then we have the fourth eye here. So for the eye we have also a quad with these 3 which goes in there and this one. So there must be a 6 in there. So 6 must go there. 1, 2. This is the same. So the 6 goes here, which means this is a 5, 6. Then we have, I remove the 1 here, 2, 4, 9 here, and then 1, 6, and then either 7 or 8, because it could be anything, not 9 but 8. And this is 3, 5 on the palindrome, 3, 5, 7, 8. Oh, but now I can look down. Here there's no 9, which is the second cell on the palindrome, so there's no 9 here either. There's no 1, so it can't be neither 9 nor 1, so it's just 2. And these are 1, 9. I don't know if it's interesting to I will write it down. So still can't decide. Well, we have a 7-8 pair here, so this can't be 7-8, and because of the palindrome here either. No. This is this one and this one and this one. Oh, we have a 1-2 pair here, so we know that we're missing a 3 and a 4, and here the 2 missing are 7 and 8. But let's not. Well, it could go. Can't decide yet. We need to decide from the top. So now I will look here, but it's more complex because of the modular line. We have 3 of each entropic line, 3 of each entropy, or so low, 1, 2, 3, medium, 4, 5, 6, and high, 7, 8, 9. And then, let's say if it were low 1, yes, it would work. This would be medium and high, but for this line segment, this would be another low, say 3, or possibly a 1 again. That's the difficulty, because these two do not see each other, so it's not like the German whisper line or the renban. They could repeat, possibly. But I think it's more interesting to think about the palindrome first, because we know these three, and these are the same as these three. They do not go here nor here. So it's the same as this from the palindrome here. So this is what goes on the palindrome. So there's a 7 there somewhere. Well, we know it's not here, so it's not here. So 7. And we have, so these 6 are goes on the entropic line, and they must be different, although they could theoretically be the same, these two, because of these are, so these 3 goes here, and these 3 goes here. They must be all different because of the palindrome which goes here. And now it's interesting because let's continue. Here 6 is either 1, 5 or 2, 4, so there's no I there. There's a low and a medium. These 3 must contain one of each, including an I digit, so these are one of each, which are these 3. So it must be there must be an I here, which is not 7 but 8 or 9. Then 14 is either 5, 9 or 6, 8. These 3 goes in there. They must contain a low digit, there's a medium and an I. They must contain a low digit. Oh, this can't be 1, 2. Maybe this is easier to explain. We have a 1, 2 pair. So these 3 goes here. We have medium I, but we need a low, which is not 1, 2, so this is a 3. Then this is an interesting part, maybe. So here we have one of each, a low, a medium and an I. Here also low, a medium and an I, but for the whole puzzle there are 3 low, 3 medium and 3 I. So here we must have a low, a I and a medium. So this can't be 9 because there would be 2 I digits. It must be 4. So 4, so this is 5, 1. This is 2. 1, 2. 5, so this can't be 5, 9, but 6, 8, and this is the 9. So now here we have 1, 5, 9, which goes here. Except for the 9. No, this is not 1 nor 9. So this is 5. we may use the entropic line, so this is medium, low high, we don't know which one, but this is a medium, which is the 6. We need 159, we need a 9 and a 1. Well, I can't tell much. Well, 9 gives 1 here. So 9. And here 159. So this is not the 9 but the 1. So this is the 9. This is a low, which is 3. This one. And then I, which is 8, here. 3. So we have 274 for the palindrome. 2 doesn't go there, so it doesn't go there. No, here, so it doesn't go there, so it goes here. 2, 7, yes, this can't go there, so it goes here and here. 2, 7 and 4. And now this fixes almost everything, so 8, 7. That's it. So I think this is a very neat design for this puzzle. I enjoy this logic here, and maybe this is, well, I found it quite useful to think about each modularity of these three. It helped me a lot to think about this, but once you get the logic behind the palindrome and the triplet here which goes there, it's easier to think about this. So maybe I would flip upside down the puzzle, so one start with this and not start thinking about the entropic line, which is more complex to grasp. But anyway, it's a very nice puzzle.